Hello, welcome to the lecture for section 8.1b, the law of cosines. All right, when we left off in 8.1a, the lecture for the law of sines, we were looking at these two triangles, and we discussed the fact that we couldn't solve them with the law of sines. So for side angle side triangles or side triangles, we have to use the law of cosines. All right, and the law of cosines is displayed here. Whenever we have two sides and the included angle, or if we have no angles at all, just three sides, we have to use the law of cosine. A little typo there, the W. All right, and the law of cosines says that when we set up our triangle as we did before, alpha, beta, gamma for the angles, and A being across from alpha, B being across from beta, C being across from gamma, we can then say that A squared equals C squared plus B squared minus 2 times B times C times the cosine of alpha. All right, or B squared equals A squared plus C squared minus 2AC cosine beta. Or C squared equals A squared plus B squared minus 2AB cosine gamma. All right, and the law of cosines is on your formula sheet as well. It's just above the law of sines in the lower left-hand corner. All right, so let's look at these two triangles again, and let's see how we could solve them using the law of cosines. All right, so in this first triangle, we have a given side, the included angle, and another given side. We would call that a side angle side triangle, right? So let's see, there's our alpha, our beta, our gamma. So this side across from gamma is going to be C, which we don't know what it is, but A is 10 and B is 16. Okay, so I can't set up a ratio with the law of sines because I don't know the side across from the only given angle, right? But I can say that I can solve for side C, right? I can say that C squared is equal to A squared plus B squared minus 2AB times the cosine of the side across from C, gamma, right? So for this triangle, C squared is going to be 10 squared plus 16 squared minus 2 times 10 times 16 times the cosine of 30. All right, let's see what that is. 10 squared, that's going to be 100. Wake up my calculator here. There we go. All right, so 10 squared plus 16 squared minus 2 times 10 times 16 times, oops, didn't mean that, I meant times the cosine of 30 degrees. And it looks like C squared is 78.87. Well, we want C, so let's take the square root of that. And we see that it is about 8.9. And I should check to make sure that calculator was in degree mode. I think it was. It was. Okay. All right. So C then is equal to about 8.9. All right. Now, sometimes you might be tempted to go ahead and switch to the law of sines now that I can do a ratio. But please don't do that. Please, if you start with the law of cosines, finish with the law of cosines. If you start with the law of sines, finish with the law of sines. When you switch back and forth, you can open yourself up to an ambiguous triangle situation. You can open yourself up to the possibility of error. So always just use one law when solving a triangle. All right, so we still need alpha and beta. All right, so let's go ahead and Let's solve for alpha now. Solving for alpha, and I think I'm going to need more. I'll do it here. I guess it'll fit. Solving for alpha, we can say that a squared, actually I'm going to do it up here. I want more room. A squared is going to be b squared plus c squared minus 2bc times the cosine of alpha, right? So for this one, a squared is 10. So 10 squared equals 16 squared plus 8.9 squared minus 2 times 10 times 8.9, right, times the cosine of alpha. All right, so I'm going to do a little bit more algebra here because I want to solve for alpha. All right, so first, let's see, let's move all the terms that don't have, let's simplify a little bit first, all right? So we'll say that 100 equals, and I think 16 squared is 254, right? But I better not guess on these. Let's see. Yeah, 256. All right. So 100 equals 256 plus 8.9 squared, 79.21, minus 2 times 10 times 8.9. That's 20 times 8.9. Which is 178 times the cosine of alpha. So let's subtract the 256, the 79.21, and then divide by the negative 178. So 100 minus, excuse me, 256 minus 79.29, I'm sorry, 0.21. 21, there it is a negative 235.21. All right. So then that's going to be equal to negative 178 times the cosine of alpha. So if we divide both sides by negative 178, we'll have the cosine of alpha. So then we take the inverse cosine of both sides, and we'll see that alpha is equal to the inverse cosine of negative 235. It's a negative over negative, so it'll become positive. So 235.21 divided by 178. Uh-oh, domain error. I must have done something wrong here. Let's see. Let's do that subtraction again here. 16 squared, 8 point. All right, so let's see. 100 minus 256 minus 79.21 negative 235.21. Divide both sides by, what is that, 20 times 8.9? Is that one? So let's check that calculation out. 20 times 8.9, it is 178. Oh, that's the problem. That's not supposed to be 10. That's supposed to be 16. There. All right. So let's fix that. 32 times 8.9. It's 284.8. There's our error. So 284.8. All right, so now we need to divide by negative 284.8. Yeah, this is going to be better. And divide that. Okay, so now let's see what alpha is. It's going to be the inverse cosine of 235.21 divided by 284.8. There it is, 34.3 degrees. All right, so that's our alpha. Now all we need left is beta. We need left is to find beta. So for that one, we'll do that, I'll erase and we'll do that right here. Okay, b squared, we're using this version of it now, is equal to a squared plus c squared minus 2ac times the cosine of beta, right? So b squared, 16 squared, is equal to 10 squared plus 8.9 squared minus 2 times 10 times 8.9 times the cosine of beta, all right? So 256 is equal to 100 plus 8.9 squared, which is 179.21, minus 20 times 8.9 times the cosine of beta. All right, 20 times 8.9 is 178. Cosine of beta. All right, let's subtract that 179.21. All right, so 256 minus 179.21 is that 76.79. Now we're going to divide it by negative 178. All right, so oops, now there's another problem there. Now I don't know why I didn't want to do that. Let's try this again. 250, we're going to write this down. So 256 minus 179.21. Oh, I know I hit minus and negative probably. All right, so we're going to write it as 76.9. And then we'll divide both sides by that negative 178. That's going to be the cosine of beta, right? So then beta would be the inverse cosine of this ratio, the inverse cosine of 76.9 divided by negative 178. All right, so inverse cosine of 76.9 divided by negative 178. And there we have 115.6 degrees. And there's our beta. All right, does it make sense? I'll add these up and I should add to 180 or close to 180. We're off by just a little bit because of some rounding error. Okay. Now there's nothing that much different in solving a side triangle like this one here. We know no angles at all, but all the lengths of all the sides. So it doesn't really matter where we begin to solve this. We just need to pick one of the angles and then go from there. All right, so let's see. I'm just going to say that this is my alpha, that's my beta, and that's my gamma up there. So that means 10 is my A, 8 is B, and C is 5. All right, so I don't know, let's just solve for alpha first. So that means I want to use the version of the equation that has alpha in it, right, that has alpha in it. So the version I want to use is this first one here, because that's the one that has alpha in it. Okay, so I'm going to say that A squared, or 10 squared, here, this one, A squared equals B squared plus C squared minus 2 times B times C times the cosine of alpha. All right, so A squared, that's 10 squared equals 8. B is 8, so 8 squared plus C is 5. 5 squared minus 2 times 8 times 5 times the cosine of alpha. All right, so 100 is 64 plus 25. Is that 89? Minus 16 times 5 is that 80. Cosine of alpha, subtract that 89, so 11 is negative 80. Cosine alpha, right? So then alpha is going to be the inverse cosine of 11 over negative 80. Let's see what that is. Inverse cosine of 11 over negative 80. It's 97.9 degrees. Or I could round it up to 80, but I think I'll keep it there. All right, so that's our alpha, 97.9. Okay, and we can find beta and gamma the same way, right? Beta, we're going to use the b squared version of it. So we'll say b squared is a squared plus c squared minus 2ac times the cosine of beta, right? So this is going to be 8 squared is equal to 10 squared plus 5 squared minus 2 times 10 times 5 times the cosine of beta. So 64 is 125 minus 20 times minus 100 cosine beta. So negative 61. When we subtract the 125 from both sides, negative 61 is negative 100 cosine beta divided by negative 100. Right? So then beta is equal to the inverse cosine of negative 61 over negative 100, which is just 61 over 100, right? Well, let's see what beta is. Inverse cosine 61 divided by 100. It's 52.4. All right. And then, you know, I could do the law of cosines again to find gamma, but I'm really lazy. So to find gamma, I'm going to say that's 180 degrees minus 97.9 minus 52.4. Because we know the interior angles of the triangle add to 180, right? 97.9 minus 52.4. And there we go, 29.7. All right, so there you have it, the law of cosines. Okay, so a couple of things to think about. If you can solve a triangle with a law of sines, you should. Just go for the law of sines. If it doesn't work, then you want to use the law of cosines. And it's not going to work for a side angle, side triangle, or a side triangle. So whenever you have these two types of triangles, you have to use the law of cosines. All right, never switch back and forth between the law of sines and the law of cosines. Whatever you start with, you end with. All right, and here's a page that summarizes very nicely when to use the law of sines and when to use the law of cosines. Again, with the law of sines, if you have an angle side triangle, or if you have a side angle triangle, and this side angle is the ambiguous triangle, so there might be two. There might be two, right? When you have a side angle side or a side, you use the law of cosines. Okay. All right, so that ends the lecture for section 8.1b, the law of cosines.